Hi there, my name is Dickson Wong. I'm an award-winning and multilingual tutor at the Profs, having graduated from the LSE. 97% of my A-level students achieve at least a grade B or higher, with 72% achieving A stars and A's, and a boast of 100% success rate when it comes to my GCSE students achieving at least a grade 6. So today, I'd like to go through with you two example questions on where two planes are perpendicular to each other, on how do we know that they're perpendicular to each other, and what do we do with that piece of information. So let's get started. So here I have my first question here. We were given the equation of two planes. This is the equation for the first plane, and this being the equation of the second plane. And part A says that show that the point A, 2 minus 2, 3, lies on the second plane. Well, okay, well, that's not too hard, right? What we need to do is to substitute the 2 minus 2, 3 into R and see if the right-hand side also equals to 1. If it does, then it's consistent, and therefore point A lies on plane 2. So let's do that. So we sub that in here. So I got 2 minus 2, 3, and I'll do the dot product with the coefficient of I, J, and K, which is 1, 5, 3. So 2 times 1 is 2, minus 2 times 5 is minus 10, 3 times 3 is 9. Add these numbers together, indeed that equals to 1. Therefore, we can say that point A lies on the second plane. Okay, straightforward. Part B shows that the two planes are perpendicular. Okay, so that's going to be the key to solving this question. So how do we know that two planes are perpendicular to each other? Well, the short answer is if you do the dot product between the two sets of normal vectors, i.e. 2 minus 1, 1 and 1, 5, 3 here, if the answer equals to 0, then they will have to be perpendicular to each other. Why is that? Because cos 90 equals to 0, right? If you think about, we're going to go through in a later example where we use the equation to find the acute angle between the two planes. And if theta equals to 90, cos 90, your answer has to be 0. And if we do the dot product here, it equals to 0, then obviously it doesn't matter. 0 times anything or 0 divided by anything, it's going to be 0. Okay. So we'll do the dot product between the two normal vectors here. We know that these two are n. This is how we write the vector equation for planes. These are n's, and these are the perpendicular distance from the origin. So let's do the dot product for the two normal vectors, the 2n. So that's 2 minus 1, 1. And we'll dot that with 1, 5, 3. Same exercise. 2 times 1 is 2. Minus 1 times 5 is minus 5. 1 times 3 is 3. Add them together and you get 0. Indeed, 0. Therefore, we can conclude that the normal to the plane 1 is perpendicular to the normal of plane 2. And hence, these two planes are perpendicular. Part C. Find in vector form an equation of the straight line through A, which is perpendicular to the first plane. Well, first of all, the vector equation to the straight line is R equals to A plus lambda B, where A is any point on the line, lambda is the scale factor, and B is the direction vector. Okay. Now, A, we can just pick any point we like. Well, what do we know? It goes through point A. So A could be the point. And we also happen to know what is the coordinate of A, which is 2 minus 2, 3. So we can just put that in. So for A, that's going to be 2 minus 2, 3 plus lambda. Now, this is the direction, right? We can look back at, it says go through A, and we know the normal vector, essentially the direction of the plane. And we know this to be 2 minus 1, 1, and that could be our B. And we're done. And that's part C. This is written in column form. If you want to write this in vector form, then you can write it simply as R equals to 2i minus 2j plus 2k plus, and then take out the lambda, and then 2i minus j plus k. Okay. D, determine the coordinates of the point where this line meets with the first plane. Now, if you think back at GCSE or even just normal A-level maths, how do we find the intersection between two things, between two lines, between two planes, or one line and a plane, right? Simply use the substitution method. Sub one equation into another, and we can do that. So that's exactly what we're going to do. We can sub one equation to another one. So here, what do we have? We have 2 plus 2 lambda for the x, minus 2 minus lambda for the y, and then 3 plus lambda for the z, okay? And we could simply put it into the equation. So let's do that. So we say 2 plus 2 lambda, which is the I, plus minus 2 lambda, minus 2 minus lambda, plus 3 plus lambda, and this is the k. This is the j. Okay, all of this, we can do the dot with 2i minus j plus k. And we'll set this to equals to 0. This is quite difficult to read it like this, all right? But that's why I prefer to write it in column vector. Column vector will be much easier to see. So if I write this in column vector, I have 2 plus 2 lambda, 2 plus 2 lambda, minus 2 minus lambda, 3 plus lambda. And here I can just simply write them as numbers. I can just write them as 2 minus 1, 1, and set that to equals to 0. Again, set it to 0 because it's perpendicular, right? We said before, if you do the dot product, it equals to 0, then it has to be perpendicular. Okay, but now it's much easier, right? Because I can simply multiply this out. I will have 4 plus 4 lambda. This times minus 1, so plus 2 plus lambda. This times 1, so just 3 plus lambda equals to 0. Okay. Collect the like terms. So I have 6 lambda plus 9 equals to 0, and then I can solve that lambda is minus 3 halves. Once I know lambda is minus 3 halves, I could put it back into either one of these equations, whichever you prefer, column form or in vector form, whichever you found easier, you're going to get the same answer anyway. And if you do that, you should get the point where the line meets the second plane, and you should get minus 1, minus a half, minus 3 halves. And that answers part D. And for part E, it says that find the perpendicular distance of A to this point that we just worked out on plane 1. Okay, well, how do you find the distance between 2 points? Simply find the difference between the x, y, and z, square them, add them together, and then do the square root. So that's exactly what we'll do. Recall that the coordinate of point A up here is 2, minus 2, and 3. And this point that we find on plane 2 is minus 1, minus a half, and minus 3 half. So we'll find the difference now. So let's do the x first. So that's going to be 2 minus minus 1. Square this. Plus minus 2 minus minus a half. Square this. Plus 3 minus 3 halves. Square this. Sorry, this should be, excuse me, this should just be 3 halves. So then you got 3 minus 3 halves. Okay, so again, just put this in your calculator, nothing complicated, and you should get 3.67 to 3 significant figures. And that's the answer, and that's the distance required. And we're done with this example. Okay, so let's move on to a second example here. All right, a different question, also utilizing, very similar to what we've done in the previous example. So let's get to it. So what do we have here? We've got 2 different equations now, right? Written in Cartesian form this time. Find to the nearest degree the acute angle between the 2 planes. So this is the formula that I just now mentioned when I was going through the first example. You want to do cos theta A dot B. So these are just a direction vector of those 2. On the plane, it's just going to be normal vectors. And on the denominator, you times them by the modulus, which is simply the magnitude for each one of them. Okay, so let's just do that. So A dot B, well, we can turn x, y, and z into just normal vectors, right? So for the first plane, just going to be 1, minus 2, minus 3. And for the second plane, it's going to be 6, 1, minus 4. To find the magnitude, simply square all the coefficients, add them together, and then square root. Just like that. Okay. And from here, just put in your calculator, and you should get 54 degrees to the nearest degree as required. Okay, nothing too difficult. That's part A. Part B then. Now we have a point P, 2, 3, minus 1, and the line L is perpendicular to the first plane and passes through P. But this line L also intersects the second plane at the point Q, and we were asked to find point Q. Okay, so first of all, we know this to be a line. We literally just did what is the equation of the line as R equals to A plus lambda B. And I know 2 points on this line, right? That's going to be P and Q. So R, we could say that PQ and A can be just any point, either P or Q. I don't know Q, so I have to pick P. So P is 2, 3 minus 1 plus lambda. B is just a direction, right? Do I know the direction of the direction of the plane 1 because it's perpendicular to plane 1? Well, yes, I do. That's just going to be the coefficient of the x, y, and z. That's the normal vector, which is the direction. And because it's perpendicular, we know it's going to be the normal. So we can just take the coefficient, which is 1 minus 2 minus 3. Okay. And of course, I can write this, make it easier. So 2 plus lambda, 3 minus 2 lambda, minus 1 minus 3 lambda. Okay, and we know this intersects with the second plane. So what did we just say in the previous question? When two things intersect, sub one of them into the other equation. This is your x, this is your y, this is your z. This is your Cartesian for the second equation, second plane equation for the second plane. So literally, let's just put that in. So it's going to be 6 times x, which is 2 plus lambda, plus y, which is 3 minus 2 lambda, minus 4, z, which is minus 1 minus 3 lambda equals to 7. Okay. And you can go ahead and just solve this, just multiply the bracket out and then solve it. And you should get that lambda is minus 3/4. And since we know lambda is minus 3/4, we can just simply put it back into here, right? And then we will work out that Q, put it back into here, and we'll get Q have the points 5/4, 9/2, and 5/4. And that's part B. Okay, so for part C then, now it says we have a third plane. This third plane will pass through the point Q and is perpendicular to both the first plane and the second plane. Okay, so what we can do first is we can do the cross product between the normal vectors between the two planes. So if we take that's going to be 1 minus 2 minus 3, and we will cross that with 6, 1 minus 4. Now, one of the shortcuts that I like to use is, first of all, you can use your thumb to cover up 1 and 6. So you're left with the numbers minus 2, minus 3, 1, and minus 4. And then just like you will find the determinant of a matrix, you do minus 2 times minus 4, which is 8. And then 8 minus 3 times minus 1, which is minus 3. So 8 minus minus 3, that gives you 11. And then for the next number, cover up minus 2 and 1. So you're just left with 1 minus 3, 6, and minus 4. Again, do the same method. 1 times minus 4 is minus 4. And then minus 3 times 6, which is minus 18. Minus 4 plus 18 is 14. But beware, with this shortcut, the second number, whatever answer you get, you have to put a minus sign in front. So we just got 18. So, sorry, 14. So we're going to put a minus in front. That becomes minus 14. Now for the last number, cover up the bottom two numbers. So you're left with 1, 1 minus 2, 6. So 1 times 1 is 1. Minus 2 times 6 is 12. So 1 plus 12, that gives you 13. Okay, and this is the n, right? In the question, they want us to give it in the form of r dot n equals to p, and this is your n, right? And we did that by doing the cross product between the two sets of normals. Okay, that's going to be your n. Now, how do we find p? Well, to find p, we simply have to do the dot product between the normal vector and the point that we just found. And it doesn't matter. We know 2 points now. Originally, we only know P. Now we also know Q. So you can just do the normal vector and you can just dot it with either one of these points. And you should be able to work out P, right? Because R is just a position and it doesn't matter which one is it. So, let's just for simplicity let's just take P, which we already know is 2, 3 minus 1. And also just to protect ourselves, just in case we got Q wrong, right? But we know for sure P is going to be 2, 3 minus 1. So we'll dot that with the n that we just found, which is 11 minus 14 and 13. So what do we have? Well, 2 times 11 is 22. 3 times minus 14 is minus 42. and minus 1 times minus 13 is minus 13. So that's going to give us minus 33. And that's P. So therefore, to give the equation to the plane, we can simply write that as R dot N, which is 11 minus 14, 13, equals to P, which we just worked out to be minus 33. And that's how it's done. If you found this video to be useful, please give it a like and subscribe to our channel where we give tutees like you the insider knowledge that you need to get ahead of school and help you get the best grades possible. Together, we will help you thrive to reach your academic goals. And if you think anyone will benefit from this video, please share this and also leave any questions in the comment section below. If you'd like to improve your further maths performance, then please don't hesitate to get in touch with me or with our team of professionals. The contact information is on your screen right now. I'm Dickson Wong from the Profs. Thank you for watching, and I wish you the very best of luck with your studies.